Now, at the last time, I had you measure the pictures that you have, and everybody had their pictures, and everybody that was in class had their pictures. That was good. We used small rulers, okay, reduced rulers. Okay, some of them reduced down by a factor of about 2, and some of them were reduced down to about 60% of that size. Some people had trouble reading the smallest ones, so used the next larger, but that's going to be very sufficient. And when you do measurements with the really large pictures that I have on the website, you're going to be able to get some really, really good, precise data that will pretty well confirm the estimates that you've made, but it's going to modify them slightly. Okay, it'll give you a good idea of what kind of data you had, what kind of data we had as a group, and how good that data was. And it turns out it was pretty good. Okay, so like I said, you all deserve to give yourselves a pat on the head. And if you haven't been a part of this process for the last couple of weeks, I'll give you stuff that'll allow you to give yourself an even bigger pat on the head. Okay, do everything we ask, and things should work out well for you. Okay. So we have this data. This just says that when people measured the drops and everybody measured pictures of the same size, that the first person measured one drop that was in the 5 to 6 millimeter. Well, we called the small marks, they aren't really millimeters, we call them whatevers. So in the range of 5 to 6 whatevers, this person got 1. In the range 4 to 5 whatevers, that was 1. In the range of 3 to 4 whatevers, that was 3. There were 3 drops that had dimensions between 3 and 4 whatevers. 5 drops that had dimensions between 2 and 3 whatevers. 8 drops between 1 and 2 whatevers, and so forth. Now, one thing that we saw, we didn't really look at it till near the end, but it's worth looking at right now, is it looks like around 5 whatevers was kind of the limiting size. Nothing was much bigger than 5 whatevers, except for a couple of people that got 8 or 9 whatevers. Now, how did that happen? Well, that happened because some people were using the more greatly reduced ruler. And it turns out that these results are extremely consistent. That if we look at the reduction factor between the two rulers, if we reduce the largest measurement that was obtained by the 2 people that used the tiny rulers down to what they would have gotten if they'd used the larger ruler, which would have, of course, given them a smaller measurement, it works out almost perfectly, more perfectly than one would expect. But sometimes, the perfection is kind of a normally distributed quantity, and we just happen to hit near the middle of that distribution. Now, you don't really need to understand that, but if it makes sense to you, it's worth thinking about. Okay. Now, this assignment for today was then to take these results and figure out the total volume of water in those drops in units of cubic whatevers. Whatever being whatever the smallest mark on the ruler that you used was. Some people did that and got good results, but most people either didn't understand the instructions or had one kind of a problem or another. And this includes some people who are doing extraordinarily well in the course, so it's not because anybody wasn't smart enough to do it, it's because there's something in the instructions, I don't know what it was. But see, now we're in the position of, let's say, the manager of some kind of a big project or the head of some kind of big project that is asking data from the group, and the data is really good. I mean, this is the data that the group got, okay? So the group contributed really good data, but then when asked to go one step further, there were some problems. So now, if I'm in the position of the manager, I've got to look at what was done and start asking myself questions. How do we get the variation in the results that we get? Okay? And what do all these results really mean? Because there's some ambiguity in how you would calculate these volumes. So the first thing we want to do is we want to take these four estimates, four perfectly reasonable estimates, and figure out how much volume there is in these drops. There are 10 drops here. They have diameters in this range. So we're going to approach that problem in a minute. How would you approach that problem?